Okay, solving simple equations. This is 4.1. So an equation is a statement that has two expressions that are equal. So they give you some examples. Here's this first expression, and this is your second expression, and they're equal. So it's basically having two things, one thing on the left side of the equal sign, another polynomial or something on the right hand of the equal sign. To solve an equation, we reorganize it so that the variable is alone on one side of the equal sign. This is called isolating for the variable. When we move something over the equal sign, we perform the opposite operation. So when we move something over the equal sign, we perform the opposite operation. There's a couple of examples here. 2x equals 8. Can somebody tell me what the operation between 2 and x is?
Multiplication.
Yeah. So to move the 2 to the other side of the equal sign, so that I can isolate for x, I have to actually divide both sides by 2. So I have to do the opposite operation to both sides. The reason why I do that is, what's 2 divided by 2? Well, that's just 1. And 8 divided by 2 is 4. Now, I don't actually have to put this 1, so I can just write it as x equals 4. And what you can imagine is that these 2's will cancel out. We can do a check to make sure we've done it correctly. And this is called a left side, right side check. So what you do is you take your 4, you take x equals 4, and you plug it into the left side of your equation. So 2 times 4, what does that equal? That equals 8. So my left side is equal to 8. And on my right side of my equation, I already had 8. So does my left side equal my right side? Yes. So if left side equals right side, you've done it correctly. Perfect. Let's go to the next one. This 4 is performing the operation of addition. If I want to move it to the other side, I have to subtract it from both sides. Plus 4 minus 4. Actually, maybe I should just rewrite it. Plus 4 minus 4 is going to cancel. And so on my left side, I'll just be left with x. And on my right side, I'll be left with 6 minus 4. 6 minus 4 is 2. Let's do a left side, right side check. So let's do a left side, right side check. The left side was equal to x plus 4. And we figured out that x was 2. So my left side should equal 6. The right side of my equation is 6. So left side equals right side. Therefore, answer is correct. Let's look at C. What operation is 2 performing in this case? So again, what's the operation that 2 is performing on this left side?
Dividing.
Yeah, so to isolate for x, I have to do the opposite of that. And what I do to one side, I always have to do to the other side. I have to do the opposite operation to 2. So instead of dividing, I have to multiply. And when I do that, these 2's are going to cancel. And then I'll get x all by itself. And in this case, x looks like it's equal to 20. Over here for this one, I see that I have x minus 3. I have to do the opposite of negative 3, which is positive 3. And what I do to one side, I have to do to the other side. These 3's cancel. And I will get x equals 8 plus 3, which is the same thing as x equals 11. The root of an equation is the value of the variable that makes the equation true. It is the same as the solution of an equation. So they give us a couple of examples here. They say find the root of each equation. I have 2 plus x equals to negative 5. Does anybody have a suggestion for what I should do to get x all by itself?
Subtract 2.
Yeah, 100%. But you got to make sure when you're subtracting 2 that you're subtracting 2 from both sides. So I have a plus 2. I have to do the opposite to this side. What I do to one side, I do to both sides. These 2's will cancel. And I'll be left with x equals negative 5 minus 2, or x equals negative 7. Let's do a check. Let's check our left side. My left side is equal to 2 plus x, and I just figured out that x is negative 7. So 2 plus negative 7 is negative 9. Or sorry, negative 5. My mistake. The right side of my equation is equal to negative 5. Therefore, left side equals right side. I know I've solved for x correctly. Let's go to B. So for B, see how I'm subtracting 8 from this side? I got to make sure I do the opposite to both sides. So I got to make sure that I add 8 to both sides. That way, this 8 and this 8 will cancel. I'll be left with x is equal to negative 19 plus 8, or x is equal to negative 11. Let's do a check. My left side is equal to negative 8 plus x, or negative 8 plus negative 11. And negative 8 plus negative 11 is equal to negative 19. My right side is equal to negative 19. Therefore, left side equals right side. When solving a multi-step equation, we go in the opposite order of BEDMAS. So this is a really important thing to make a note of here. So BEDMAS says normally first I do my brackets, then my exponents, then division, then multiplication, and then addition and subtraction. Now I'm actually going to try doing them in the opposite order when I want to isolate for x. So subtraction would be the first thing I want to do. I look at my subtraction over here, and I got to do the opposite of that. So I actually have to add 17 to both sides. What that's going to do is it's actually going to get rid of my 17s from this side, because minus 17 plus 17 is going to cancel off. So I'll get 4x over here, and then 15 plus 17, that's the same thing as 22, or 32, I should say. Now, I don't have any addition to do, but it looks like there's some multiplication going on between this 4 and the x. So I actually have to do the opposite of that to both sides. So instead of multiplying by 4, I actually have to divide both sides by 4. And that way, I can get x all by itself. So x is going to equal to 32 divided by 4, which is the same thing as 8. We can actually do a left side, right side check right now. So let's do a left side, right side check. My right side is equal to 15 from here. And my left side is equal to 4x minus 17. So we just figured out that x is actually 8. So let me plug it in that equation. Let's see if we can figure out what's 4 times 8. Well, 4 times 8 is going to be 32. And 32 minus 15, let's just punch it in here. 32 minus 15 is 17. Oh, it should actually be 32 minus 17. I mistakenly wrote 15. So let's just check those numbers one more time. So 32 minus 17 is 15. Therefore, left side equals right side. And I know I've done it correctly. Let's go on to the next one. 3x minus 5 equals negative 23. So BEDMAS says if I want to do BEDMAS in the opposite direction, let me start with subtraction first. I see that there's subtraction going on here with this negative 5. So I actually have to do the opposite and add 5. And I have to make sure I add 5 to both sides. This minus 5 and this plus 5 are going to cancel off. And I'll be left with 3x equals negative 23 plus 5. Negative 23 plus 5 is negative 18. And then what I can do is I can actually now move on through BEDMAS. I don't have any addition. I don't have any multiplication. Whoops, I lied. I actually do have multiplication. This 3 and this x are multiplying. So I have to now do the opposite and divide by 3. And I got to make sure I do that to both sides. 3's are going to cancel. And I'm just going to show that I'm doing my work here because I ran out of space. X is equal to negative 18 over 3. And that's the same thing as negative 6. Let's do our left side, right side check. The right side of my equation is equal to negative 23. And the left side of my equation is equal to 3x minus 5. I just figured out that x is actually negative 6, so I can plug that into my equation. 3 times negative 6 is negative 18. And negative 18 minus 5 is negative 23. So therefore, left side equals right side. So there's no subtraction going on in this case, but I do have some addition for this example. See how I'm adding 7 to this side? Because I'm adding 7 to that side, I have to do the opposite operation, but I have to make sure that I do it to both sides. What's going to happen is now these 7s are going to cancel. And I'll be left with 52 minus 7 equals negative 9x. I can figure out what 52 minus 7 is. It's actually 45. And I can keep going on with BEDMAS. I see I have some multiplication going on. So this negative 9 is multiplying with this x. I have to do the opposite operation and divide both sides by negative 9. This negative 9 and this negative 9 will cancel off. And I'll be left with x equals 45 divided by 9. We can actually punch that in to see what that is. 45 divided by negative 9. And it's negative 5. I'm not going to do a left side, right side check for this one. Instead, I'm going to go on to question D. In question D, again, I see that I'm adding 14 on this side. So I actually have to subtract 14, and I have to subtract 14 from both sides. These 14s will cancel, and I'll be left with 2 minus 14 equals 3x. 2 minus 14 is negative 12. And then I can divide both sides by 3. Negative 12 divided by 3 is negative 4, and x is equal to negative 4. The football team needs new lettering on their jerseys. If the printing fee is $50 and it costs $8 per jersey, how many can be printed for $298? Well, let's do this. Let's say let x be the number of jerseys that will be printed. My cost is the $50 that they're going to charge me, plus $8 per jersey. So again, my total cost is $50 plus 8 times however many jerseys I want to print. We know that my cost has to be $298. That's how much money I have in my pocket. And so that's how much money I can spend. I can't spend any more. So my cost has to be $298. Let's see how many jerseys we can print for $298. So essentially, I want to isolate for x. In order to do that, let's take this 50 and let's move it to the other side. Or rather, what I should say is we're adding 50 on this side. So I have to subtract 50 from this side, and I have to subtract 50 from the other side. These 50s will cancel. And over on this side, I'll get 298 minus 50 equals 8x. 298 minus 50 is 248. And now this side over here has 8 times x, so I have to do the opposite operation. And I got to make sure I do it to both sides. Those 8s will cancel. And I'll be left with x equals 248 over 8, or x equals 31. Therefore, 31 jerseys can be printed for $298. Every time you guys have a word problem, I want you to use a similar type of solution method, or I want you to solve your problems in a similar kind of way. This is called a less method. Let me actually write it here. What does the less method stand for? Well, the L stands for a let statement. See how I identified what X is? That's what you have to do in a let statement. If you're going to be using a variable, you have to tell your audience, the person who's going to be marking your work, reading your work, using your work, what your variable is equal to. You then have to come up with an equation and then you need to show your solution. Finally, the last thing you need is a statement. You need a therefore statement just to conclude your work. So every time you guys are solving a word problem, I want you guys to use this same method to solve your word problems. You need a let statement, you need an equation, you have to solve and find a solution, and I need a therefore statement. That's how you get 4 out of 4 marks, level 4, 100%, whatever you want to call it.